Let's talk about how to find the limits of exponential functions. Your typical exponential function should look like this. F of x is equal to a to the power of x, where a could be any number. You could have 2 to the power of x, 3 to the power of x, 0.5 to the power of x. But before we get into solving any problem, there are two important graphs you need to have in mind. So the first graph is like this, and then the graph is drawn this way. You have a curved line. So this is traditionally your y-axis, this is your x-axis. Now we are assuming that this graph goes to the left, and then this is to the negative infinity, and then this is to the positive infinity. So this graph extends to the positive infinity, the graph here extends to the negative infinity. So this graph is true when you are plotting a number of a to the power of x, where a is greater than 1. So when a is greater than 1 and you plot a graph of a to the power of x, this is the graph you get. So this graph simply tells us that as the limit is approaching positive infinity, the value of the function is approaching infinity too. As the limit is approaching negative infinity, the value of the function gets closer and closer to 0. So these two points are very, very important. And then for your second graph, let's say you're plotting a to the power of x, and you have your graph like this, unlike for a values greater than 1. If you have a values between 0 to 1, and you plot them on the graph, they look like this. So it will look exactly reverse of this one. And then this is your positive infinity for your x values. Then these are y values. Here, this is your negative infinity for your x values. So positive infinity around here, negative infinity around here. If you're plotting a graph where the base of the exponents is between 0 to 1, your graph would look like this. If it is greater than 1, your graph would look like this. So if you notice one thing from this graph, as the x value of the function is approaching the negative side of infinity, the function itself is approaching infinity. As it is approaching the positive side, the function itself is approaching 0. You need to keep these ideas in mind. So let's look at examples. So for the first example, I would say if you're asked to find the limits as x approaches infinity of 2 to the power of x. Now remember, we simply plug in the limit value here. So this will be 2 to infinity. Now the base number here is greater than 1. Now, and this graph is for a value is greater than 1. If you notice, as the x value is approaching infinity, the resulting value of the function is also approaching infinity on the y-axis, right? So this value here, this function is equal to infinity. So for a counter example, say we are asked to find the limits as x approaches negative infinity of 2 to the power of x. You can pause the video and try to solve this one yourself. So like before, I'll simply plug in the infinity value into the x value here. This will be 2 to the power of negative infinity. So 2 to the power of negative infinity, if you notice, as the x value is approaching negative infinity, this function gets closer and closer to 0, or values of the base number greater than 1. And notice the base number here is greater than 1. So this is equal to 0. Let me take one other example. Say I'm asked to find the limits as x approaches infinity of 2 over 3 to the power of x. You can pause the video and try to solve this one yourself. So like we did before, I'm going to be saying, okay, this is equal to, I'm plugging the infinity value straight up. So I'll have 2 over 3 and then an infinity value. Now 2 over 3 is 0.666666 reoccurring, but I can approximate it to 0.67 to infinity. So 0.67 to infinity. If you notice, 0.67 falls within this range of 0 to 1. It doesn't fall within this range. As a function of 0.67 is approaching a positive infinity, because you have positive infinity sign there. It's approaching positive infinity. You would notice that it gets closer and closer to 0. So as it gets closer and closer to 0, that means the limits as our function approaches infinity is equal to 0. Let's take more complicated examples. So say we are asked to find the limits as x approaches infinity of 2 to the power of x plus 3 over 3 to the power of x plus 1. You can also pause the video and try to solve this one yourself. So the first thing I want to do is to rewrite this function to simpler form so that I can take the limits. I could say the limits as x approaches infinity can be written as 2 to the power of x, because there's a plus 3 here. In indices, this can also mean times 2 to the power of 3 divided by the same base again. This one, so I'll be simplifying it. So this will be 3 to the power of x times 3 to the power of 1. I can still further simplify it by saying limits as x approaches infinity of, I can break these two out of each other because I have a x power here and a x power here. So I'll put them in one fraction, and I have a constant power and a constant power here. I'll put them in one fraction. So this is 2 to the power of x divided by 3 to the power of x times 2 to the power of 3 divided by 3 to the power of 1. So since they have the power of x here, I can still rewrite this as the limits as x approaches infinity of 2 over 3 to the power of x times 2 to the power of 3 is 8 over 3. Since these two terms are multiplying each other, I can take the limits individually so that I'll have the limits as x approaches infinity can be 2 over 3 to the power of x times limits as x approaches infinity of 8 over 3. So if you notice this value, it is in the form of 2 over 3 to the power of x. And we know what happens when we have 8 to the power of x. So as x approaches infinity for 2 over 3, now 2 over 3 falls into a value between 0 to 1. So as x approaches positive infinity for 0 to 1, the limit is 0. So that means that this is equal to 0 times the limits as x approaches infinity of 8 over 3 is still 8 over 3. So this is 8 over 3. And then this is equal to 0 times 8 over 3 is 0. Let me take another example. So say you're asked to find the limits of 2 to the power of 2x plus 3 divided by 3 to the power of 2x plus 3 as x approaches infinity. So like we did before, we can take the exponents and simplify them. So this would look like the limits as x approaches infinity of this exponent is 2 to the power of 2x times 2 to the power of 3. So divided by 3 to the power of 2x times the base number still 3 to the power of, then this one 3. So I can still simplify that and say limits as x approaches infinity. Now, if I have something like this, 2 to the power of 2x, I can rewrite it as equal to, now this 2 to the power of 2x can be written as 2 to the power of 2 bracket x. So that 2 to the power of 2 will be 4x. So that's what will happen here. So I'll say 2 to the power of 2 is 4x. So I have 4x times 2 to the power of 3 divided by 3 to the power of 2 is 9x times 3 to the power of 3 is 27. So from here, the limit as x approaches infinity of 4 over 9. I will separate them directly to the power of x times 2 to the power of 3 is 8 over 27. If I take the limit as this one approaches infinity is 0, so this is 0 times 8 over 27. 0 times 8 over 27 is 0. So for another example, we have the limit as x approaches infinity of 2 to the power of x plus 2 to the power of minus x divided by 2 to the power of x minus 2 to the power of minus x. So I can immediately plug in my infinite value to see what happens. As I'm taking the limit to infinity, this becomes 2 to infinity plus 2 to the power of minus infinity divided by 2 to infinity minus 2 to the power of minus infinity. 2 to infinity is infinity plus 2 to the power of minus infinity is 0 from our graphs divided by 2 to infinity is infinity minus 2 to the power of infinity is 0. So in the end, I have infinity over infinity. Now this is indeterminate. We can't have infinity over infinity. So this is indeterminate. That means I need to find a way to resolve this limit. So to do that, I'll try factorization. So I'm factorizing 2 to the power of x for the numerator and 2 to the power of x for the denominator. So that I can rewrite my limit as the limits as x approaches infinity of 2 to the power of x, open bracket. Factorizing 2 to the power of x from 2 to the power of x is 1. Factorizing 2 to the power of x from 2 to the power of minus x, I have plus 2 to the power of minus x divided by 2 to the power of x. This is divided by, then factorizing 2 to the power of x here, I have 2 to the power of x, open bracket, 1 minus the same thing for here, 2 to the power of minus x divided by 2 to the power of x. So I can rewrite this limit as the limits as x approaches infinity of, I can separate this, so it's be 2 to the power of x over 2 to the power of x times, in this case, I have 1 plus. Now I'm going to solve this outside for you to see if I plug the answer here. So if I have 2 to the power of minus x over 2 to the power of x, this can be equal to, now 2 to the power of minus x can be written as 2 to the power of minus 1 brackets x, right? So that if I expand this bracket, it gives me back this. So I have 2 to the power of x, then this can become 2 to the power of minus 1 is basically 1 over 2. So this can quickly become 1 over 2 to the power of x divided by 2 to the power of x. In this case, if I put everything together, this can become 1 over 2 divided by 2 everything to the power of x. Now remember, 1 over 2 is being divided by 2. So this is 1 over 2 divided by 2 to the power of x. If you simplify this, it becomes 1 over 2 times 1 over 2 to the power of x. So this is equal to 1 over 4 to the power of x, right? So this is what you're going to plug in back to here. So this is 1 over 4 to the power of x, everything to the power of x, divided by 1 minus 1 over 4, everything to the power of x. Clean up space, so that here we can plug in our infinity sign. So 2 over 2 is simply 1. So this is 1 to the power of infinity times I have 1 plus 1 over 4 as x approaches infinity divided by 1 minus 1 over 4 as x approaches infinity here. As 1 approaches infinity, the answer is still 1. If we were to plot a graph of x and y, and you have 1 to the power of x, whatever you plug in here, the answer will still be 1. So as x1 approaches infinity, the answer is still 1. So this is equal to 1 times. Now this approaches 0 from our graphs before. This approaches 0. So this is 1 times 1 over 1. 1 times 1 over 1 is still 1. So the answer to this problem is 1. So that's how to solve problems or limits to infinity of exponential functions. If you like the video, leave a thumbs up, share with your friends, and subscribe to the channel. Thanks for watching.